Hello everyone, welcome to Tutor IMG's short medical series. In this lecture, we're going to be taking a look at AVNRT and what it is. AVNRT, as the name implies, of course, is AV-nodal Reentrant Tachycardia. Now, when we say AV-nodal Reentry Tachycardia, we should understand that this implies that the problem lies within the AV node. Assuming that this is now an enlarged representation of the AV node, there are two kinds of cells found in here. One kind is the fast conducting fiber, and the other is a slow conducting fiber. An important concept to understand is that the fast conducting fibers also have a longer resting period, while the slow conducting fibers are quicker to recover. They have a short refractory period. Now, most of individuals with, most of the individuals will have physiologically these fibers present, but they don't end up in tachycardia. The reason for that is because the SA node usually is the one that's exerting an effect. When the SA node sends an impulse, it will travel down both these pathways, but because it's going to go down the fast pathway faster, it will hit the His-Purkinje system first and propagate into the ventricles. Remember, electrical current can flow in either direction within these conducting pathways. So when it comes down this pathway, it will not just travel down here, but also go back up here. As it goes back up here, it does meet the impulse that was traveling slowly down, sauntering down the slow pathway. Both of these collide and cancel each other out. So this is what happens in a usual SA node run world. The problem arises when there is a disturbance in the SA nodal firing. Imagine that the impulse sent by the SA node is now not hitting or not arising at the right time, what we call a premature atrial contraction. When this premature atrial contraction comes in, what will it find? It will find that the fast fiber that just conducted the normal impulse is in a resting phase. So it cannot travel down here because this fiber is resting. However, this slow fiber is active because, well, it's faster recovery. So the impulse is just going to travel down the slow fiber, find its way down into the His-Purkinje system through this channel now. At the same time, it's also going to try to come back this way. Now, the time taken for the impulse to travel down the slow fiber is long enough for the fast pathway to have recovered and opened up. So this block basically just disappears by the time that the fibers, the slow conduction happens and travels back up. What this does is it sets up a new circuit, a circuit independent of the SA node, a circuit that keeps going around and around here, and it's called the slow fast AV-nodal circuit. This slow fast AV-nodal circuit will keep sending impulses down into the His-Purkinje system, as well as sending impulses up here into the atria, depolarizing them as well. So what is happening? In the SA node run world, the SA node is sending an impulse to the AV node, which is then sending an impulse to the His-Purkinje system. So we get a P wave when that happens, and a QRS complex when this happens. But in this world, where now we have the AV node setting up a circus movement, sending out impulses to both the ventricles and the atria, the image would look something like this, with the AV node now running the show and sending impulses to the atria as well as to the ventricles. So because now the impulse is traveling in the opposite direction, our P wave will end up looking something like this, the opposite of what it should look like. Whereas, well, this impulse is pretty much the same, so we end up getting the same kind of QRS complex as before. Now, because these impulses are traveling at the same time, you will not see the regular gap occurring between the P and the QRS complex. Both these are happening at the same time. So the P wave, which is now supposed to look something like this, will end up being superimposed on the QRS complex, and it will end up either being swallowed and disappearing in the QRS complex, or, as usually happens in narrow, the supraventricular tachycardias that we see here in this situation, it will end up looking something like this. It will end up looking something like this, buried within the QRS, giving rise to a wider, or what we call a pseudo, S wave, or sometimes it will end up looking like a pseudo R wave, R prime wave, right? And that's the presentation that I'm going to show you in our next short video, where we will discuss in detail the ECG findings of AV-nodal Reentrant Tachycardia. Thank you for joining me for this video, and stay tuned for part 2 to look at the ECG findings.